I was wondering when you would get here and do this lesson. Okay, this is Mr. Bryce. I'm with Susquehanna Valley High School in Concord, New York. Bryce at svsabers.org. We're doing Unit 12, Lesson 2, Sets and Probability, Common Core Algebra 2, the non-Regents version. And this is a Venn diagram. Since the basic calculations in probability involve counting the number of outcomes that fit into a particular event, it makes sense to have a tool to visualize and keep track of all the outcomes in the sample space. We'll do this by using sets. Recall the basic definition of a set. Set definition. A set is simply a collection of things. You can have numbers, you can have objects like balls and bats and erasers, etc. So to satisfy a well-defined criteria, all things that are round, balls, planets, spheres. The things that are contained in the set are called the elements of the set. Okay, set A is defined as a collection of all integers that are greater than 0, less than 10. Write it in roster form. La di da 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 da. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why didn't it put 0 and 10? Has to be greater than 0 and less than 10. Show set A in a Venn diagram form. This will be a very simple Venn diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9. Integers. Okay. A subset, oh yeah, that rectangle is important. A subset is any set whose elements are all contained within another set. These integers are a subset 1, 2, 3, 4, 5, 6, 7, 8, 9 are a subset of all the integers. Give two possible rules that can define a subset of A and write them as B and C. So let me see. I can do this two ways, where there aren't any subsets and where there are subsets. So I'm going to do it where there are subsets. So B's definition is going to be integers such that X is between 2 and 7, and integers such that 4 and 9. And then write the sets in roster form. 3, 4, 5, 6. 5, 6, 7, 8. They have to be curly. If I would have had that underlined, 4 is less than X, which is less than or equal to 9, set D would be 5, 6, 7, 8, 9. Got it? So let's finish answering this question. Give two possible rules. Done. Define the subsets of A. Okay, there are subsets. Everything is there. In other words, everything in B is also in the original set. Everything in C is also in the original set. Do sets B and C have any elements that are in common? Yes, they do. Let me see. They have 5 in common and 6 in common. So a subset of both is 5 and 6. Okay, now let's go on to exercise 2. Sorry about that diversion. Consider an experiment where we first toss a coin and write down its outcome, and then roll a 6-sided die and write down its outcome. Write the set of ordered pairs, for example, H, 4, that represent all outcomes for this experiment. Okay, there are easy ways and hard ways to do this. Let's do the easy way. Heads, 1, heads 2, heads 3. You see the pattern? Heads 4, heads 5, heads 6. Now what am I going to do? All the tails. Tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. Okay. Write a set of ordered pairs. Write a set of ordered pairs to represent an event of getting a tail and an even number. Call this set A. So we're going to do all of them. It doesn't say do all of them, but we're going to do all of them. Write a set of ordered pairs to represent all of the events of getting a tail and an even number. Remember, we want the tails in a 2, tails in a 4, tails in a 6. It says call this set A. That means we have to put it in braces. If you call it a set, we have to have it in braces. I changed question D. Okay, let's do C. The complement of set A will be all the events in the sample space S that don't fall into set A. The complement. Oh, you complete me. Everything that's missing in me is inside of you. Okay, complement. Write the complement of set A. All the heads. There aren't any heads. That's what's missing. And also the odd tails. I said odd tails. That's it. What is missing? That's the definition of complement. It completes the set. Find the probability of A, not and the probability of B, and also the probability of B. You'll find out later on why that's very important to keep your English language straight using probability. Find the probability of A. 1, 2, 3. 3. Oh, by the way, we should write probability of A equals 3 out of 1, 2, 3, 4, 5, 6, 12. Probability of B equals 1, 2, 3, 4, 5, 6, 7, 8, 9. There has to be a better way than that. There is. We're going to find out soon. 9 out of 12. Interesting. Set A and its complement are important. When we look at probability, because all outcomes either fall into an event or its complement, but not both. They don't cross. Different textbooks use different notation to denote complements. Since notation is not universal, we'll simply refer to complements by name instead of symbol. Really? That's the complement of N. Okay. Draw a Venn diagram that illustrates the sample space S and sets A and B. Since we already defined sample space, since we already defined set A and set B, we can abbreviate. They don't cross. I wasn't paying attention. Consider rolling a single 6-sided die and recording the results. Let A be the event of falling, of having a number greater than 4. Let B be the complement of the set. Draw a Venn diagram. Okay, we got it. Now, find the probability. Let me see. We have counting theories, but we only have one event here happening. We only have one thing that's happening here. Event of rolling number greater than 4, that's A. So what numbers are greater than 4? 5 and 6. 1, 2, 3, and 4. Okay. Find the probability of A. Let me see. There are 2 of them out of 6. Probability of B. Let me see. There are 4 of them out of 6. If you don't understand, you have to ask me or rewind. I'm just counting them. 1, 2. 2 out of 1, 2, 3, 4, 5, 6 out of 6. What's true about the probability of A plus the probability of B? Let me see. 2 out of 6 plus 4 out of 6 equals 6 out of 6, which is 1. Will this always happen with a complement? Prove the probability of an event with a probability of a complement will always be 1. Ah, cool. So let's say the probability of A equals X out of 20. The probability of B is everything that's left over. What is left over? Well, how do you find out what's left over? You do 20 minus X over 20. Now add them together. X over 20 plus 20 minus X over 20 equals X plus 20 minus X over 20. What happens to those two? They cancel each other out. You have 20 over 20, which is just 1. Beautiful. We use this relationship, the fact that they have to add up to 1, all the time without even thinking about it. Try the following. Answer each of the following question problems using a relationship developed in exercise 3D. If the probability I'll draw a red marble, pick up a red marble from a bag is 3 out of 17. Really? What's the probability I won't draw a red marble? What's left over? 14 out of 17. Okay, how many times are you actually pulling a red marble out of a bag? If the probability I open up the refrigerator and there's going to be, an orange 3 out of 10 times, 3 out of 10 times, the only thing that's left are apples. How many apples are there? 7 out of 10. That might happen in real life. Okay, if the probability it will rain tomorrow, bingo, is 20%, what's probably it won't rain tomorrow? 100% minus 20% equals 80%. Hey, Mr. Bryce, didn't you say you liked fractions? Yes, I did. 80 out of 100. In theoretical probability calculations, the set that makes up the sample space can get difficult to write out. It's good to remember things like tree diagrams. 2 4-sided dice are rolled, and the number on each side is noted. Draw a tree diagram that represents all the outcomes in the sample space, and how many are there? Remember the last time I drew a tree diagram, I had flip 1, flip 2, flip 3? Well, now it can be roll 1 or die 1, and roll 2 or die 2. So on the first die, you can have a 1, a 2, a 3, or a 4. A 1, a 2, a 3, or a 4. And if it comes out to be a 1, 1, 2, 3, 4. Or a 1, 2, 3, 4. Okay, got it? How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Wait a minute. How many was the first choice? 4. How many was the second choice? 4. How can the numbers 4, 4, excuse me, how many different ways how can the numbers 4 and 4 get to 16? That's what we'll be thinking about. What's the probability you don't get two of the same number? Okay, so I can't have 1 and 1, but I can have 1 and 2, 1 and 3, 1 and 4. I can have 2 and 1, 2 and 3, 2 and 4. 3, 3, whoop, get rid of that one. So it's 12 out of 16. Looking good. What's the probability you're going to do your homework tonight? 1, right? So do the next 2 pages. I'll see you in class. If you have any questions, make sure you ask. Mr. Bryce, signing out. Peace.